If a number times itself is equal to another number, then we say that the first number is the square root of the second number. And we may write a is equal to the square root of b, where a is the first number and b is the second number. From what we know about exponents, we can also write a times a is equal to a squared. We can use substitution to write that a is equal to the square root of a squared, and it's also true that a squared is equal to b. The symbol we have used to indicate square root is called the radical symbol. The square roots of all counting numbers are either counting numbers or irrational numbers. Let's use a calculator to look at the square roots of the first 10 counting numbers. Here's the square root of 1, which is 1. The square root of 2, which shown here is rounded to the billionths place. Here's the square root of 3, another irrational number. And the square root of 4, which is the counting number 2. The square roots of 5 and 6 are shown, and they're both numbers between 2 and 3, as are the square roots of 7 and 8. And then when we get to the square root of 9, the answer is 3, so we say that 9 is a perfect square, as are 4 and 1. And then finally, the square root of 10, an irrational number just over 3. And here's a list of the perfect squares of the first 12 counting numbers, where 1 represents 1 squared, 4 represents 2 squared, 9 represents 3 squared, and so on. These numbers are called square numbers because they can be written as squares using an array of dots. Here's 1. That does not look much like a square, but how about 4? Or 9? And let's look at 2 more. 16, which is 4 squared, and 25, which is 5 squared. We've talked about counting numbers so far, but here's a fraction. 1/2. 1/2 times itself is equal to 1/4. So we say that 1/2 squared is equal to 1/4, and the square root of 1/4 is 1/2. Here's another number which is not a counting number. It's 2.25. It has a square root that's not an irrational number, 1.5, because 1.5 times 1.5 is 2.25. But I hope you can see the relationship between 2.25 and the perfect square 225, which has a square root of 15. Every positive number is both the square of a number and the square root of a number. Usually those two numbers are different, but there's one special case, and that's the number 1. 1 squared is 1, and the square root of 1 is 1. Well, let's go back to the square root of 2, shown here, rounded to the billionths place. Often when we're working with the square root of 2, we choose to round it off. Perhaps we'll round it to the nearest tenth, 1.4, or the nearest hundredth, 1.41, or even the nearest thousandths, 1.414. But if we want to talk about the square root of 2 as an exact number, we just write this, and we often pronounce it root 2. Here's another counting number, 48, which has an irrational square root, a number almost 7. Not quite 7, but almost 7. We know that the square root of 49 is exactly 7, so we're not surprised that the square root of 48 is 6.928, and so on, another irrational number. Well, we can round this, 6.9 to the nearest tenth, or 6.93 to the nearest hundredth, or 6.928 to the nearest thousandth. But once again, if we want to write it exactly, we can write it like this. But we also choose to do something with this and write it slightly different. And that's because 48 is the product of 16 times 3. And 16 is a perfect square. So we take the square root of 16, 4, we write it outside the radical symbol, and we get 4 times the square root of 3. And this is called simplest radical form, and it is often read 4 root 3. We're going to try it again with the square root of 12. If you'd like to turn off the video, you may, and try it yourself first before you check the answer. Well, we look at the square root of 12, and we know that it's 2 times 6, but we also know that it's 3 times 4. And 4 is a perfect square, so that's the product that we're going to use. And the square root of 4 is 2, so we get 2 root 3 as simplest radical form for the square root of 12. And we'll try one more. Again, if you'd like to turn off the video and try it first, be my guest. We take a look at the square root of 45. We know that it's 3 times 15, but it's also 9 times 5, and that's the one we want because 9 is a perfect square. If a number does not have a perfect square as one of its factors, it can't be written any simpler than it already is, like we found with root 2. But in this case, we have 9 times 5. The square root of 9 is 3, and our answer is 3 root 5, simplest radical form for the square root of 45. This lesson looked at square roots, squares, perfect squares, and simplest radical form.